Exercise 2.3, Problem 15, Discussion. If A, B, C, D are in a GP, prove that A plus B, B plus C, and C plus D are also in GP. Okay, it's a tricky problem, but we can solve it. So, it's a GP, and A, B, C, D are in GP. Okay, and we need to prove that these are all also in GP. So, if these are to be in GP, then what is the condition? T2 by T1 equal to T3 by T2. Any series you want to prove as GP is T2 by T1 equal to T3 by T2. For AP, what it is? T2 minus T1 equal to T3 minus T2. Okay. So, B plus C divided by A plus B must be equal to C plus D divided by B plus C. If that is proved, then this is in GP. Okay, now come back here. It is first term, second term, third term, fourth term. So let's take the first term to be A and the common ratio is R. So if you write it, then this will be A and the second term will be AR and C will be AR square and D will be AR cubed. Okay. So exactly like last time, we'll have to do it. So replace A as A as A only, B as AR, C as AR square and D as AR square in this equation and simplify it, we'll be able to get the right side. Okay. So broadly explained, let me summarize it here. So given A, B, C are in geometric sequence, we need to show that these are in GP, but exactly what we mean is B plus C divided by A plus B must be equal to C plus D divided by B plus C. That's what we need to prove. Okay. So the formula is T2 by T1 equal to T3 by T2. This is the formula to show any series, to check whether any series is in GP or not. So let A and R be the first term and common ratio of the geometric sequence. So what will happen? The second term is B. When you give A and R, it becomes AR. The third term is AR square, and the fourth term is AR cubed. So we are equating the second term to B, which is the second term given here. The third term to C, which is the third term given in the series, right? It's a third term, 1, 2, 3. Then D, AR cubed is the fourth term, and that's the fourth term D given here. So you get this information. Now, and you also know, if you have to prove in a GP, which I've been telling in the few seconds back, that T2 by T1 will be equal to T3 by T2. So if you want to show these three are in GP, this divided by this must be equal to this divided by this. That is B plus C divided by A plus B will be equal to C plus D divided by B plus C. If you can prove this equation, then these three are in GP. Now how will you do that? Substitute B equal to AR, C equal to AR square, D equal to AR cubed in 1 and simplify the LHS and RHS and check whether they are equal. So put all these things here on the left hand side, you will get something in terms of A and R. Do the same for the right hand side, you will get in terms of A and R and see whether they are equal. Okay. So let's do the problem. It's the same. A, B, C are in geometric. A and R, we are assuming it is the first term of the common ratio. So this leads to B is equal to AR square, C is AR square and D is AR cubed. We know T2 by T1 must be equal to T3 by T2. By putting that for this, we get B plus C divided by A plus B equal to C plus D divided by B plus C. Now the problem starts. So substitute B equal to AR, C equal to AR square, D equal to AR cubed in 1. So what will happen? So B plus C will be AR plus AR square. That's what is written. And A plus B is A remains same and B is AR. So if you look at this, you can take AR commonly out. So you will get AR into 1 plus R. And here you can take A commonly out. It becomes A into 1 plus R. So this 1 plus R and 1 plus R will cancel. A and A will cancel. So it will become R. So the LHS B plus C by A plus B reduces to R once you put that B is AR, C equal to AR square and D equal to AR cubed and simplify it. Okay. Now you got to do the same for the RHS. What is RHS? C plus D by B plus C. What is C? C is the third term. Third term is AR squared. D is fourth term. Fourth term is AR cubed. So B is second term. So it's AR. C is third term. AR squared. So here you can say C. AR square is common. So AR square into 1 plus R. Here you can see AR is common between these two. So once you take AR, it becomes AR into 1 plus R. So again 1 plus R and 1 plus R will cancel. A and A will cancel. R will go in R square. R times. Thus you can see the right hand side also reduces to A. The left hand side also reduces to A. So which means the LHS equal to RHS. So which means these three are in GP. Okay. So let me recap. So all you need to do is that let's take the A be the first term and R be the common ratio and get the first four terms, which will be A, AR square and AR cubed. Right. And in the given problem they say the terms are A, B, C, D. So you have to equate them. So A will remain A. The second term of the series is B, and that will be AR. And the third term of the series given in the problem is C, and that will be AR square. And the fourth term is D, so that will be AR cubed. So take these values, substitute in the left hand side and the RHS, simplify it and see whether you are getting the same value. You will get the same value, and that's why the series A plus B, B plus C and C plus D is a GP. Okay, and I forgot that if you want to show any sequence as a GP, you have to use that formula T2 by T1 equal to T3 by T2. So when you apply to this series, this will become B plus C divided by A plus B must be equal to C plus D divided by B plus C. So that's the equation which you need to prove. So you substitute all this B value, B, C, D in terms of A and R in that equation and simplify it. Okay. I hope you understood the problem. If not, please review it. Okay. It's more of a simplification problem. Thanks for watching the video.